Yo, what's going on guys, Tanmay here for Simple Snippets and welcome back to another video tutorial on data structures and algorithms, and today's topic is going to be postfix to infix conversion using stack data structure. So in this part we are going to take a look at the rules and the pseudocode required to take a postfix expression and convert it to infix expression, and we are going to use the stack data structure to make this conversion possible. Now before we go ahead, we've already talked about infix, prefix and postfix expressions, why we need them. We've talked about infix to postfix conversion using the manual process. We've also talked about infix to postfix using stack data structure. So this video is exactly the reverse process, because here we are going to take a postfix expression and convert it back to an infix expression. So if you've missed any of the previous tutorials, I will drop this entire DSA course, DSA playlist in the video description. Do check it out. If you already know all those concepts, you're good to go. Please make sure you watch this video till the end. It is very important. It is a stack data structure application. And with that being said, let's get started. If you're new to my channel, my name is Tanmay Sakpal and I do a lot of computer science and information technology video tutorials like computer programming, development, technology talks and a lot more on this channel. So if that's something you're interested into, then definitely subscribe and turn on the notifications to get the latest updates and never miss out on such important topics. Now before we go ahead with the rules and pseudocode of postfix to infix conversion, as you can see on the screen, I have question number 1 written over here which says convert this postfix expression to infix, and in the brackets I've written manual method, and then over here we have the same question which says convert postfix to infix, and this time we are going to use the stack. Okay, so before we head with the stack data structure use case, let's quickly see how manually the postfix expression will be converted to infix, and I'm directly going to show you the solution because we've already seen how to convert postfix to infix manually in previous tutorials, so we'll not waste time. However, we will note down the result of this postfix to infix manual method so that we can cross check it and verify it with the result of the postfix to infix using stack data structure. Okay, so this is the postfix expression. We have AB plus C minus DEF raised to star G divided by. Now if you followed previous tutorials, we are taking this example throughout all the tutorials. That is because this example pretty much covers all the rules, all the possible use cases. And this is a postfix expression which needs to be converted to the infix format. And you can see initially we convert this and this part to its appropriate infix format and then assume it as x1 and x2. So a plus b is assumed as x1 and e raised to f is assumed as x2. Substituting that, we get this expression. Then we convert x1c minus to its proper infix format, and we convert dx2 raised to into its appropriate infix format. Again we substitute x1 minus c as x3, and we substitute d raised to x2 as x4, so we get x3 x4 star g divided by. Then star comes over here and we get x3 star x4 as the infix format. We consider it as x5 and we get x5 g divided by, and ultimately we get the result as x5 divided by g. And after resubstituting all the values which we've held over here in temporary variables, we get the final answer, and I've written it over here again. And you can see there are a lot of brackets, and that is because in infix expression we require brackets to determine which part of the infix expression happens first. The other way is to have the operator precedence and associativity, or you can use brackets. When we use brackets, brackets have the highest priority, and depending upon the innermost bracket, that expression will happen first. So in this case, in our final answer, you can see a plus b has to happen first, then this bracket will happen. Okay, and when I say happen, it means evaluated. Over here also, this inner bracket happens first, then the outer bracket, and then this whole outer bracket, and the result is then divided by g. Okay, so this is how the evaluation will progress. And the reason why things get complicated in infix expression is because of operator precedence and associativity. So for example, if I write a plus b star c, and if I say a is equal to 3, b is equal to 4 and c is equal to 5, I can solve a plus b first. So 3 plus 4 star 5. If I say 3 plus 4, it would be 7 star 5. This would be 35. However, I can also do b star c first. So again 3 plus 4 star 5. So in this case 4 star 5 will give us 20. So 3 plus 20 will give us 23. So you can see we are getting two separate results, and this is why we require operator precedence and associativity in infix expressions. We do not require operator precedence and associativity when it comes to prefix and postfix expressions, and that is why those are more convenient and efficient in algorithmic evaluation. That's the whole point of it, right? But anyways, that's why we are getting these brackets over here. So ultimately what we want is, when we use a stack data structure to convert this very same postfix expression to its infix format, we want this answer. Okay, so what we'll do, let's write this answer over here in the manual conversion, and then now we will go ahead with the stack conversion, and then we will cross verify and cross check both the answers if we get the same answer. Okay, so I've written the manual conversion answer over here, and now that you've seen the manual conversion answer, let's talk about the rules and pseudocode of postfix to infix conversion using a stack data structure. So when we use a stack data structure, obviously we need to follow certain rules, follow certain pseudocode, and basically this rules is just converted into pseudocode. So rules and pseudocode are one and the same thing. However, pseudocode is a representation which looks like part code and part text, which can be easily converted to any programming language code. Okay, so pseudocode is pretty much language agnostic, which means that it is independent of any one particular programming language. So if you see this pseudocode, and you can use this pseudocode in any programming language, any general purpose programming language, and write a program in that language to convert a postfix expression to its infix format. Okay, the rules are more English way of representing the entire process, entire working. So let's first go ahead with the rules. When it comes to rules and the pseudocode, it is pretty easy compared to infix to postfix. In infix to postfix, we had many rules and the pseudocode was also kind of complex. But when it comes to postfix to infix, the rules are simple and we have only 4 rules. Okay, so starting off, the rule number 1 is scan the postfix expression from left to right. So over here I have the same postfix expression. We have a, b plus c minus d and so on and so forth. I have created a stack over here, and we will scan this expression from left to right in this direction. So starting from index position 0 to the last index position. So when we speak programmatically, this string will have its index positions. At every index position we'll have a symbol which can be an operand or an operator, right? So this is rule number 1. For this rule number 1, we have the pseudocode statement, which is this point number 2, which says loop I equals to 0 to postfix.length. So in this pseudocode, what we're doing, we're creating a function postfix to infix, which will accept a string, which is the postfix string or postfix expression. Step number 1 is to create a stack data structure. We will say stack S. So S is basically an object when we actually write a program. Then we will loop from I equals to 0 to this postfix.length. Okay, so from 0 to the length of the postfix, which can be in this case from 0 to 12, right? Index position 0 is this starting position and this is the ending index. So this is that rule, scan postfix expression from left to right. That translates to a for loop in the pseudocode perspective. Let's see rule number 2. Rule number 2 says if the incoming symbol is an operand, push it onto the stack. Now if you observe this expression, this postfix expression, which is a, b plus c minus d, f raised to star g divided by, you can see that we don't have any brackets. And that's the reason why things are a little simple over here, because in postfix or prefix expression, we do not require any brackets. So the only 2 possible cases can be either the character, either the symbol can be an operand, operand can be a variable, variable means a, b, c and so on and so forth. It can be a constant, right? It can be a constant which is a number 1, 2, 3 and 4 and so on. Or it can be a sub expression, which means a plus b can be collectively considered as operand 1 as well, right? So this can also be considered as one operand. So this whole thing, for example, let me write an expression over here, a plus b star c minus d. So for this star operator, the 2 operands are this sub expression and this sub expression. So this is op1 and this is op2. So this is what I mean by sub expressions being one particular operand, right? So only these 3 things can be operand. So in that case, we have to push the symbol, that is the operand, onto the stack. Simple rule. So for rule number 2, in the loop we have 2.1, which says if postfix of I, that is the index position that we are scanning in the postfix expression, if that symbol is an operand, just push it onto the stack. s.push. Pretty basic. Okay. So this is 2.1.1. And this is rule number 2 in the rules part. Let's see rule number 3. Rule number 3 is for if the incoming symbol is operator. So if it is not an operand, if it is not A, B, C, it is an operator. Operator is something which performs some operation on the operands, which can be plus, minus, star, divide by and raise to. So in our case, we are considering only these 5 as operators. So if the incoming symbol is an operator, what we have to do, we have to pop 2 operands from the stack, which are there already in the stack. Then we have to take this operator and add the incoming operator in between the 2 operands. We have to add opening and closing bracket to the whole expression that we are just forming and push this whole new expression string back into the stack. Okay, sounds a little tricky. Let me just demonstrate an example. Let's say we have A and B as operands in the stack, and now we get plus as an operator. So what this condition says, if this incoming symbol is an operator, it is an operator plus. What we have to do, we have to pop 2 operands. So we will take B outside, we will take A outside. The next thing we have to do is add this incoming operator in between the 2 operands. So we have to say A plus B. So plus comes in between because remember we are converting a postfix expression to its infix format. In infix, remember the operator always comes in between the 2 operands. So we say A plus B. So this is what we formed so far. And lastly, we also have to add an opening bracket and a closing bracket. So we've pretty much popped these 2 operands from the stack. We have formed this A plus B as a new expression. We've added the opening and closing brackets. And lastly, we have to say and push this whole new expression string back into the stack. So we have to push this entire string back into the stack. So we will say A plus B, opening and closing bracket, and this is now pushed into the stack. Okay. So this is considered as one operand now. So this will be considered as OP1 the next time we get an operator. So let's say now we get C, we push it onto the stack, and now let's say we get a new operator. Let's say we get minus. So in that case, we will pop C, C will come over here and pop this A plus B and with the brackets as one operand. So A plus B as one operand, we will put minus in between. We will then say C, and then we will again add more brackets. So we've popped this out, and now we've created this entire expression string, and we will again put this back into the stack. So now we will get A plus B in brackets and then minus C into this larger bracket. Okay. So now you can see how the infix expression is formulating from this postfix expression, and of course things will get more clear when we actually dry run this entire pseudocode onto our example. Right now I was just trying to showcase and demonstrate how things would work. But this is rule number 3, and for rule number 3 we have 2.2 statement which says else if postfix of I is an operator, if it is an operator, that is if the symbol that we are scanning is an operator, we first say op1 is equal to s.top. We then say s.pop, so we pop out that particular operand which is stored in op1. Then we say operand 2 is equal to again the top of the stack, and then we remove that top of the stack. And lastly we create this expression exp which says opening brackets, so we have to add opening brackets plus op2 plus postfix of I plus op1. And the reason why we say op2 first and then op1 is because the stack operates in last in first out. So the last operator will come out first, which will be in op1. So last operator has to come at the right? And you'll understand this when we actually dry run it. I know I'm just saying it and it might not make sense, but anyways, here's where the expression will form, and then we have to push this expression back into the stack. Okay. And then we again end this loop because that's rule number 3. That's about it. And the 4th rule basically is when this entire loop will complete itself, when you completely scan the entire postfix expression, it says at the end, pop and print the full infix expression from the stack. So at the very end, after this entire looping happens, after you scan through the entire postfix expression, the only one last result that would be there in the stack would be the actual infix expression. So we simply have to pop and print it out and we will get the final answer. Okay. So these are the 4 important rules and corresponding pseudocode for postfix to infix conversion using stack data structure. It's kind of easy compared to infix to postfix because there was opening and closing brackets involved over there. Over here we don't have opening and closing brackets in the postfix expression, and hence fewer rules and fewer lines in the pseudocode. If you're taking notes, you can note down these rules note down this pseudocode. It is very important for your exams perspective and for understanding this. Or you can take a screenshot. I'm obviously going to be sharing all this pseudocode, these rules, some theory, as well as the final C++ code of Postfix to Infix using stack in the video description on our official website, so you can check that out as well. But now let's actually dry run this pseudocode on our example. We've been just talking through the rules and we've understood a little bit of basic, but now let's actually implement this pseudocode on our example so that this idea, this working gets very clear to us. Okay, so let's dry run this pseudocode because the pseudocode represents these rules only. So we can go ahead with the rules or we can go ahead with the pseudocode, and I would prefer pseudocode because we are going to write a C++ program in the next tutorial to implement the pseudocode. So starting off, this function will start and the very first step is to create this stack. The stack is created over here. Then we have a loop. The loop says we have to go from I equals to 0, which means this index position, to postfix.length, that is to the length of this postfix string. So from left to right till the last. Okay. Inside this loop, obviously, let's start with running this loop. So at the very beginning, we will be at I equals to 0. So let's track I. I'm going to write I equals to 0. Now we will say 2.1, which is if postfix of I is an operand. So what symbol is there at index position 0? We have A. A is an operand, right? If it is an operand, we have to push it onto the stack. So I'm going to write A over here. Let's use another color. I'm going to use orange. A. Okay. So this is the top of the stack. Okay. So since this if condition is executed, that is since 2.1 is executed, obviously 2.2 will not be executed. We will come at end of the loop. And then again, we'll go at the start of the loop where I will become 1. So I has now become 1. We will come from 0 to index position 1. Over here, again, B is an operand. So again, 2.1 will be executed, right? So 2.1 is again an operand. So if it is an operand, we have to push it onto the stack. So I'm going to write B over here. B comes as the top of the stack. So this is the new top of the stack. Okay. So since if condition was executed, the else if will not be executed. That's how the if and else if block works, right? So now I will become 2. Let's move forward. At index position 2, we have a plus. Plus is an operator. So if postfix of I is an operand, no. This 2.1 will not be executed. We will go to 2.2. 2.2 says else if postfix of I is an operator. Is it an operator? Is it plus, minus, star, divide by, or raise to? Yes. Doesn't matter which operator. It just has to be an operator, okay? Because there is no precedence and there is no associativity rules involved in postfix expressions. So no matter which operator, we have to do these steps only. And that's why we have less rules. So in that case, we say op1 is equal to s.top. So let's create op1 over here, or let's write op1 over here itself. op1 is equal to s.top. What is the stack of top right now? It is B. So op1 will be B. So this is done. Then 2.2.2 says s.pop, which means we have to remove this B outside this stack. Just remove it out because we've stored it in the variable op1. So now the new top is A, right? A is the new top. So at 2.2.3 we say op2 is equal to again s.top, which is the top right now A. So op2 will become A. Then at 2.2.4 we say s.pop. So we remove this also from the stack. So the stack has now become empty. Moving on, we say at 2.2.5 we say exp is equal to this opening bracket. Then we have to append. So this plus is just for appending, okay? op2. What is op2? op2 is A. So I'm gonna write A over here. Then we have plus postfix of I. What is postfix of I? Postfix of I currently is postfix of 2, which is plus operator. So plus operator will come in between. Let me write plus over here. Then again we say plus op1. So this plus is for appending, okay? It is not gonna come in the expression. It is for appending or adding this op1. What is op1? op1 is B. So let's write B over here. And then we have plus this closing bracket. So we will add closing bracket. So we've created a infix expression from this first part, that is first 3 symbols, that is 3 characters of the postfix expression, and it is stored in this exp variable, string variable it is basically. And at 2.2.6 we say s.push this expression back into the stack. So I'm gonna take this same expression and push it onto the stack, and now this becomes the top of the stack. Okay. So after this, obviously else if part is done. We will come outside the else if, we will end the loop over here, again go to the start, and I will now become 3. So I hope you understood how we went through this entire iteration where we made our very first sub-infix expression from these 3 characters. And now we will move forward where I will become 3. So when I will become 3, we get C. C is what? C is an operand. So this if block will be executed. And when the if block is executed, we say s.push. So C is pushed onto the stack. So let's write C. So C is pushed onto the stack. This becomes the new top of the stack. And then we move forward. So if condition is done, we will come at the end of the loop. Again, I will become 4. I is at index position 4, which is a minus. Now minus is an operator. Okay. So again, minus is operator. So we will go in the else if part. We say op1 is equal to s.top. What is op1? op1 now will become s.top. What is s.top? S.top is C. So op1 becomes C. That is 2.2.1. Then 2.2.2 says pop that top. So s.pop will just pop off the top of the stack. That's how pop function works. So we remove this, and now the new top of the stack is a plus b with the brackets, right? So we come at 2.2.3, which says op2 is equal to again s.top. What is s.top? S.top is brackets a, then we have a plus, and then we have a b and closing brackets. So this becomes the operand 2 now. And you can see now the operand 2 is a sub expression, which is a sub infix expression. So this can also be considered as an operand. That's what I showed you initially, right? Then we say 2.2.4, which says s.pop. So we remove this entire expression by saying pop. So the stack becomes empty. Then at 2.2.5, we say a new expression is formed by using opening brackets. That is this. Then we say plus op2. What is op2? op2 is this sub expression. We say a plus b, again closing bracket. That is op2. Then we say plus postfix of I. What is postfix of I? We are currently at minus, right? I is 4. So postfix of 4 is minus, which is an operator. So minus comes over here in between. And then we say plus op1. op1 is C. So I'll write C over here, and then this is done, and then we have a closing bracket. So now we have a closing bracket. And this, guys, is then pushed into the stack at 2.2.6. We say s.push this expression onto the stack. So again, I'm going to take this expression, push it onto the stack, and this, my friends, again becomes the new top of the stack. So you can see, again, an infix expression is formed, and now we've utilized a, b plus c minus of the entire postfix expression. So let's move forward now, and let's go a little faster now that you've understood the entire process. So now I becomes 5. We are at this position, we have D. D is an operand, we push it onto the stack. So I'm going to write D over here. Then we move forward. I becomes 6. We are at this index position. It is E. E is again an operand. We push it onto the stack. Then I becomes 7. We are at this position, which is index position 7, which is again F, which is another operand. And the top is also going to change. F is the new top of the stack. By the way, our stack is not overflowing. Okay, so I don't have space. That's why it is something like this. It would still be a little longer than this. In fact, let me just draw it. Okay, so the new top of the stack is F and I is 7. So I now becomes 8. We move forward. And now at 8, we get a operator. Operator is a raised to sign. So in that case, again, we get op1, which is equal to top of the stack, which is F. So I'm going to write F over here. Then we say 2.2.1. So s.pop. So we remove this F. The new top of the stack is E. So that goes in op2. So op2 is equal to E. We remove that off also at 2.2.4. So new top of the stack is D. And lastly, we create this expression at 2.2.5. We say exp is equal to op2, that is first opening brackets. Then we have op2, which is E. Then we have plus the postfix of I, which is the operator, which in this case is a raised to sign. We'll say E raised to. Then we have plus op1. op1 is F. And then a closing bracket. And we simply push this onto the stack. So in the stack, we will get E raised to F and then the closing bracket. And now this is the new top of the stack. So now I will become 9. We move forward. At 9, we again get a raise to operator. So this is the raise to operator. So now again we have to pop two elements from the stack which will go in op1 and op2. So op1 will be e raised to f. Let's write that. So op1 will be e raised to f. We've popped e raised to f, so that will be removed, and the new top will now become d. D will be then stored in op2. op2 will become d, and then we pop this also. So d is also removed. So now new top of the stack is the only element left. Then we create this expression. We say opening bracket, we say op2, so op2 is d. Then we say postfix of I, which is a raise to operator, so I'm gonna write d raised to, and then op1 is it's e raised to f, closing brackets, and then we add this closing bracket. So we've got this expression. We will then push it onto the stack at 2.2.6. So this exp will go over here. We say d raised to opening brackets e raised to f, closing bracket, another closing bracket, and now this becomes the new top of the stack. Okay, so this was when I was 9, I now becomes 10. So we are at this position and we get one more operator. So again we have to perform 2.2. Let's do that. So we say op1 is s dot top. What is op1? op1 will be s dot top. What is top right now? We have this d raised to, then bracket e raised to f, closing bracket, closing bracket. So that is op1. So I'm gonna write d raised to opening bracket e raised to f, closing bracket, closing bracket. This is op1. Then we have op2, which is equal to the second element. So this element gets popped out, and then we have the top of the stack, which is this whole expression. So that becomes op2. And then now we have to create the expression by taking the operator we are currently at, which is star operator, in between these two operands, right? So I'll form the entire expression over here because we don't have space over here. So the expression goes as follows. We add an opening bracket, we say op2 plus the operator, which is star in this case, because we are at index position 10 and we have star over here. Then we again say plus op1 and a closing bracket. So let's build this entire expression. We have opening bracket, then we have op2. Let's copy and paste this entire op2 inside. Then we have star in between, which is multiplication, and then we have op1. op1 is this entire expression. Let me just paste it over here, and then we have a closing bracket. So this is one extra closing bracket which is appended at the end. So this, my friends, is the entire expression which is formed, and you have to pop this also. So this is the new exp, and this has to be pushed into the stack. So let's entirely cut this and paste it in the stack. And I know it is not fitting, so let me just write down a better version of this. Okay, so this is the entire exp which I have pushed onto the stack at step number 2.2.6, and now this becomes the new top of the stack. And then we move forward. We get a g at index position 11. So index position 11, we get this g, which is an operand. So we push that onto the stack. Simply push g onto the stack. This becomes the new top of the stack, right? Then we move forward, which is the last index position, which is I equals to 12. At index position 12, we get the last division operator. So it is an operator. So 2.2 has to be carried out. So in 2.2, we have 2.2.1, which says op1 is equal to s dot top. So op1 is equal to s dot top. What is the top of the stack? It is g. So this is basic. Then we pop that out. So we pop g out. Now what is the top of the stack? It is this entire infix expression which we have formed so far. So then we say op2 is s dot top. So this is the s dot top right now. So this becomes the entire op2. So I'm gonna write op2, that is operand 2, equals to this entire expression. So let me write it over here. Okay, so this is op2, and now we have to again form the expression. We will say exp is equal to opening bracket. Then we have op2, which is this entire expression. Let's paste it as it is. So this is the entire expression. Then we have the postfix of I, which is nothing but the divide by operator because we are at index position 12. So divide by operator comes in between. I'm gonna write divide by over here. And then we simply have plus op1. op1 is g. So I'm just gonna write g over here as it is. And then we have one closing bracket. So this is the entire expression. We've basically popped this op2 also from the top of the stack. So we don't have anything in the stack. And this entire expression is now gonna be pushed into the stack. So let me write this entire string into the stack. Okay, so this is the entire infix expression string which has formed in the exp which we've now pushed into the stack. So this is going to be the only top of the stack. And if you observe, we are pretty much exhausted the entire postfix expression starting from 0 to index position 12. And also in the stack, if you observe, we have pretty much got our infix expression as well. So just take a look at this and compare it with the manual conversion result. Let me just copy and paste it. So I'm gonna paste it over here and just observe this result using stack and using the pseudocode with our manual conversion result. It is exactly the same. And the only difference is extra bracket is added over here in the stack data structure conversion, and that will not have any effect because it is just extra bracket. So if you add extra bracket over here in the result of the manual conversion, the output will still be the same. So one extra bracket in the manual conversion and we have the same result. So this extra bracket doesn't have any effect onto the expression, so don't worry about that. But apart from that, we have the exact result using stack data structure, which means our pseudocode and the rules are being applied perfectly fine. What you can do is take few more examples, simple examples, apply the same pseudocode and also use the manual conversion and then cross verify the results and see what results you get. I'm pretty sure you'll get the right results, and I advise you guys to take a pencil and paper and actually practice this pseudocode, practice these rules on a few examples to get a hold of it so that you understand them in detail. And I'm assuming you guys have now got a good idea about the rules and pseudocode of postfix to infix conversion using stack data structure. Okay, so I'm gonna conclude this video over here. If you like this video, please give it a thumbs up. Let me know in the comments how this video was. Do share it with your friends, and I'll see you guys in the next video. Peace.